In these slides, we will review information presented in the text and go through some examples on detection systems. In the overall process of the depot methodology, detection is the first of three components of the physical protection system. As we covered in the text, detection has three critical steps. The first requires an alarm to be activated. Typically, this will be from someone or something entering into a sensor's detection volume. This alarm then must be communicated so that a person can judge whether the alarm was caused by an intrusion or not. The communication can be audible, where security personnel go to the site of the alarm and assess the situation, or can involve an alarm assessment system. Typically, facilities will have a central alarm station, where a tripped alarm will activate a camera that covers the same area and allows security personnel to remotely determine the cause of the alarm. In any case, security personnel must visually confirm the cause of an alarm and assess whether it is a threat or merely a false alarm. Here we have a few examples of sensors. On the top left, there are buried coaxial sensors that can be hidden underground and detect anyone walking over them. To the right, there is an active infrared sensor, which is common in heist movies. The sensor sends an infrared beam to another sensor, and if anything breaks the beam, it triggers an alarm. On the bottom, from left to right, there is a motion sensor, which detects motion in its field of vision, a camera, which can be used for assessment but can also be used as a motion detector, and on the top right of the door is a balanced magnetic switch, which alarms when the door is open. We will now go through an example that considers a simple situation where we have an active infrared sensor and a buried coaxial cable on the perimeter of our facility. We will say that the infrared sensor has a 90% probability of detecting someone walking through it. However, due to the positions of the beams, it is susceptible to someone bypassing it by crawling under it. The second sensor we will use is the buried coaxial cable. It will alarm with a probability of 70% when someone passes over it on the ground. However, if the intruder is aware of the cable, they may be able to jump over it or use something to bypass it. Now let's look at an example. The security system design requires a detection probability of 85% against the design basis threat. To simplify the problem, we will assume that the probability of assessment is 100% and that our design basis threat says the adversary can only attempt to bypass the sensor by walking, jumping, or crawling. The measured sensing probabilities for the two sensors are listed in the table here. Because the infrared detector has a probability of 90%, it already meets our requirement of 85% for both walking and jumping, but is susceptible to a crawling adversary. We therefore must couple a coaxial cable with the infrared sensor. The coaxial cable has a 70% probability of detecting a crawling adversary. However, combining the coax cable with the infrared sensor only gives a detection probability of 71.5% to detect a crawling adversary, well below our requirement of 85%. As a result, we need to add another sensor. Because our weakness is against a crawling adversary, we should add an additional coaxial cable. With a second coaxial cable, we now have a detection probability of over 91%. The calculation for this is shown on the slide. The probability of detection of multiple complementary sensors is determined by subtracting the product of their non-detection probabilities from 1. It is important to keep in mind that there is rarely ever one single detector that can detect all of the potential entry techniques that an adversary might use, and that combinations of detectors will typically provide a much more reliable detection probability when making sure to eliminate potential vulnerabilities. The last thing we will introduce is the concept of a perimeter intrusion detection assessment system, referred to as a PIDAS. A PIDAS is a combination of barriers coupled with sensing and assessment equipment designed to provide a high level of detection. On one fence, you will notice cables draped along the fence, which can detect an adversary attempting to climb or cut through the fence. In addition, PIDASes can simplify the assessment process because some effort is required to pass the first fence, and if an unauthorized person is in between the two fences, it conveys their intent to break into the facility. The space between the two fences is called the clear zone and represents an ideal place to put sensors, lighting, and cameras because there are no structures to hide behind and anyone in the area is easily visible. You may also notice that one fence is visually intimidating with numerous layers of razor wire. This provides some level of deterrence to a potential adversary. We explained earlier that deterrence is not easily measured and therefore not used in the depot calculation. However, it is still practiced. Care must be taken with the design of a PIDAS to ensure it does not open up any vulnerabilities. For example, if the two fences are too close together, an adversary may be able to bypass all of the detection means in the clear zone using a ladder.